here we're asked to solve for the area of the polygon. And we see that C is the center of this regular pentagon. Pentagon meaning 5 sides. Regular, this is an important characteristic. Regular meaning that all of the side lengths are congruent. So that's the first thing that we can do here, is recognize that we have a side length that is 12. Well, because it's a regular pentagon, we know that all the side lengths are equal to 12 and 12. And that's helpful here because we see that the area of a regular polygon is equal to half of the perimeter, which is the sum of all the sides, or the singular dimension length around the polygon. So if we start at one point, we want to know if we connect all of these sides and have a one-dimensional length, what is that length? That is the perimeter. And then that times this word apothem. So this should be new terminology, or maybe it's not, maybe it is. The apothem here, I've defined it here. It's a segment that extends from the center of the polygon to the midpoint of one of the sides, and this is important. The other characteristic is that it's perpendicular to that side. So we can see here from the center we have a segment that extends down. If this is my apothem, it creates a right angle here because it's perpendicular. And the other thing that it does is that it connects to the midpoint. Therefore, we know that this segment is congruent with this segment. Well, that's helpful because we know that the length of the whole is 12. Therefore, this segment must be 6, and this segment must be 6. Well, if we look at our formula here, the area is equal to 1/2 of the perimeter. Well, the perimeter is going to be 5 sides of 12. So we can say 5 times 12, or if we added 12 5 times the apothem, and we are not sure the length of the apothem yet. We need to solve for that apothem, and notice that the apothem here is a side in a right triangle, which we now know has another side length of 6 and a hypotenuse of 10. So we can use the Pythagorean theorem here to solve, where we say the apothem squared plus my short side squared is equal to the hypotenuse squared, and we can solve from there. The apothem squared plus 36 is equal to 100. Subtract 36 from both sides, and we get the apothem squared is equal to 64. When we take the square root of both sides, we get that the apothem has a length of 8. So if the apothem has a length of 8, we can plug that back in and finish out our formula. So the area, let's do it in a different color here, the area is equal to half of, well, 5 times 12 is 60, and our apothem is 8, which is going to be half of 60 is 30 times 8, which is going to be a final area of 240.